Hello everyone, in this video we're going to see the solution for the HackerEarth problem, a plane journey, which is the fourth problem of April Circuits 2020. So in this question basically we're given that we have some flights and we have M flights and we have B1, B2, BM as the capacity of each plane, and we have N groups of people and A1, A2, AN as the number of people in each group, and each plane can travel from source to destination with only one group such that capacity is enough, meaning it is less than equal to the ability of the plane, capacity of the plane, and all people belonging in the same group will travel together, meaning that one group cannot be broken down or two group cannot be taken as ones, and every plane can make multiple journeys between source and destination, and it costs 1 unit of time to travel between source and destination. And this is the main thing: multiple planes can fly together, and it is not necessary for planes to end their journey at the source. So we can have one plane fly from A to B and from source to destination, and it can come back from destination to source. And we have to find the minimum time required to send all the groups from source to the destination. So the main thing that you have to note is that multiple planes can fly together. So all the planes will fly parallelly, and 1 unit of time is taken to travel from source to destination. So we're given integers n and m, and we're given the in groups capacity of groups of people and the capacity of the planes, the size of the groups of people and the capacity of the plane. So let's look at the test case itself. So the test case, I'll just copy it: 4, 3, 2, 1, 2, 6, and 5, 5, 6. So, and I should increase the size. So this is the test case. So this is, let's just remove this for now. So this is the number of, this is the groups of people, and this is the planes. And we also have to tell either the time taken, or we have to tell whether if it is possible or not. If it is not possible to send all the groups, then we have to print -1. So the first intuition that you should get, or which I got, is that the largest plane, the largest capacity plane, should accommodate the largest capacity, the largest group of people. And so let's just sort both. So I sort the size of the passengers of the groups. So if I try sort the size, so it will be 6, 2, 2, 1. So these are the groups of people sorted, and these are the capacities of the plane sorted. So once you sort it in descending order, if you sort the descending order of groups of people and descending order of planes, and if B of 0, B meaning the capacity of planes, and A meaning array A containing the size, array B containing the capacity of the plane. So if B of 0 meaning the highest capacity plane, if its capacity is less than the largest group of people, then you can just say answer is equal to -1, and you can print answer. Why? Because if the largest capacity plane is not able to accommodate the largest group of people, then it's not possible, because as they said, we cannot break a group down. So for this test case, so this is there. I'll just put this in above, and then we'll work with this test case. Yeah. So let's come back to this test case. So this test case, you can see that this 6 is able to accommodate this 6. So fine. And we'll keep a track of the number of planes at source. So initially source is equal to 3, and the number of plane at destination. So number of planes at destination is 0. So the first plane, as you can see, is able to accommodate the first group of people. So it carries that group of people. So that plane travels from source to destination. So now source is 2, destination is 1, and this group is done traveling. Now this plane could have traveled with the same plane, with the plane before it, if it was able to accommodate the next group of people. So as you can see, 5 is able to accommodate 2. So 5 also traveled with 2. So at t is equal to 1, t is equal to 1 only now. So t is equal to 1. So t is equal to 1, 6 and 5 flew together from source to destination by taking 6 and 2, these two groups. So source is equal to 1 and destination is equal to 2. Now, this plane could also have flown together with the earlier two plane if it could accommodate its corresponding passenger size, and it can. So this also flows at t is equal to 1. These three fly all together from source to destination carrying these three groups. So at t is equal to 1 only, source is equal to now 0, destination is equal to 3. Now we have 1 left. So what do we do if we have 1 left but all the planes are at destination? So the best thing to do, it well, now it seems that we can call any of the plane and have them take the remaining group of people, but the best thing to do is call all the planes back to the source. So t is equal to 1 only. Now t is equal to 1 plus 1, I call all the planes back to the source. So now source is 3, destination is 0. Now any of those, now three planes are back at the source. Now any of these planes can take the remaining this to the destination. So now plus 1, because again source to destination, and the configuration will be like now first two planes are at source and the last plane is at destination, and t is equal to 3. So why did I, when we had this configuration, when source we had uh, 0 planes, when at source we had 0 planes and every plane was on destination, and we had taken 2. Yeah, so at this point I'm going back to that point. So at this point these planes are all at destination and these people have all landed to their destination. So for this one, why am I calling all the planes back? Because in this test case only this was 1. Suppose this was 1 1 1 1 1, there was a lot of numbers. Suppose it was like that. So we should call all the plane back to the if there are any groups of people left after all the planes are at destination. If there are any groups of people left, then you should call all the plane back to the destination. So which is why in this test case itself, which is why 1 was remaining. So I called all the planes back to the source, which took 1 time, and then one of those plane took the remaining, which took 1 time. So time is equal to 3, which is for this test case. As you can see, time is equal to 3. Now in this test case, well, one plane was able to accommodate its corresponding group size, but that may not be the case. So I'll show you one good example and we'll work on that. So suppose these are the number of groups of people in sorted order. So basically this is the array A, number of groups of people. The sizes of groups of people. So we have 6, we have 6, we have 5, 4, 4, and say 3, 2, 2, 1, 2. And the planes, let's say we have the planes 6, 4, and 3. Now, and as I said, we'll have source and destination. Source is now 0, destination is now 1. Destination, actually source is 3 because all the planes are at source. Destination is 0, there are no planes at the destination. Now what I'll do is I'll have two variables. This is array A and this is array B. So I'll have two variables. I'll have int I is equal to 1 and j is equal to 1. So why not 0? Why 1? Because as I said, if 0 is less than, then answer is equal to minus 1. So I'm assuming when I say I is equal to 1 and j is equal to 1, I'm assuming that the first plane has already reached the destination with the first group of people. So this destination is 1, the first plane is at the destination with my assumption. So now I'm running a loop and I is 1, j is 1. So this is j and this is I. So at the ith plane, at the ith group of people, we have the jth plane. So we find if it is able to accommodate. So is the jth plane able to accommodate the ith group of people? It is not able to accommodate. And here time is 1 initially, of course, because why is it 1? Because one plane has already landed with the first group of people. Yeah. So we come to this plane now, and we say we see whether it is able to accommodate. So it is not able to accommodate. So we have to call the earlier plane back and ask that plane to send this group, ith group, to their position. So that will take time plus 2. Why 2? Because the plane at destination, again it will have to come to source, and again it will have to come to destination by taking the next group of people. So now I is equal to 2 and j is still 1 and time is 3. So j is still 1. Why? Because this plane hasn't moved. This plane took the first two groups of people. This plane hasn't moved. Now I is equal to 2. So now we come to the second plane and this is j is equal to 1. This plane. Now again we see if this plane is able to accommodate, if the jth plane is able to accommodate the ith group of people. So it is not able to accommodate. Why? Because 4 is less than 5. So again we have to call its earlier plane back. So that will be time plus 2 again. And I is equal to 3. Y plus 2 because it was at destination. Again it came back to source to take this, and again it came back to destination with this. Now I is equal to 4, meaning that we've come to this group of people and this plane hasn't moved. So is this plane able to accommodate? Yes, it is able to accommodate. So what we do now is, first of all, we keep a max time. So max time is the obviously maximum of time. So now the maximum of time is 1 plus 2, 3 plus 2, 5. So max time is 5 is equal to 5. I'll just write that. Max time is equal to maximum of time is equal to 5. So as I said, at I is equal to 4, I come to this group of people and I is equal, yeah, at 1, 2, 3. I is equal to 3 actually if I use one base indexing. So at this group of people, I come to this plane and I say, now this plane is able to accommodate. Yes, it is able to accommodate. So whenever it is able to accommodate, I put the time again as 1. Why 1? Because this plane will will fly this while this plane was flying all the three before it. This is one important piece of information to understand. So this plane was flying all these three people coming back and forth to fly all these three groups, and among any of those 5 time, it took the first plane 5 units of time to get the first three groups, and among any of those 5 times, the plane could have started. So at the earliest, this plane could have started with this because it fit it. So now this plane went from source to destination at time is equal to 1. So now source is equal to 1 and destination is equal to 2 because the first plane and the second plane are the same. So now j is equal to 2 and I is equal to 4, meaning that we come to this plane, we come to the next plane, and we come to we come to this group of people and we come to this plane. Now again we do the same thing. We ask that is this plane able to accommodate its corresponding? If the jth plane is able to accommodate ith group of people, so 3 is less than 4, so it is not able to accommodate. So if it is not able to accommodate, then again we have to call 4 back, and if I call 4 back, it will take me plus 2 time because 4 will come back and then again it will take this to its position. So time will be 1 plus 2, 3, and then we update max time, but 3 is less than 5, so max time will say 5 at 5 for now. Now I is equal to 5 because this was just done by the latest 0, 1, 2, 3, 4, 5. Yeah, so I is equal to 5. We're at this group of people now, and j is equal to 2. So we're at this. So now we see if this is able to accommodate. So yes, it is able to accommodate. So for this again, time will come back to 1 because it could have started at any of the time before max time. So we're supposing it started at 1 itself. So time is equal to 1, and this 3 took this 3 to the destination. So now source is 0 and destination is 3. So all my planes are at destination, and these all the people, all the groups here have been covered, but these people are still left. So like I said in the example before, if all the planes are at destination and if there are still people left, then we should call all the planes back. So I called all the planes back. So source will be 3 and destination will be 0. So when I call all the planes back, I have to do max time. Now we'll be playing with max time. So max time plus plus. Why? Because it took 1 unit of time to call all the planes back. So whatever was the maximum time plane, it took that also 1 unit of time to come back. So max time plus plus. So now simply we have these groups of people and we have these plane. And because this is in descending order, each of these group of people will be able to be accommodated by each of these planes. So you can think of that this plane can accommodate any of these, this plane can accommodate any of these, and this plane can accommodate any of these. And that is the case as you can see also. So for that, what we do is after doing max time plus plus, let's say the remaining is int k is equal to the remaining number of groups, and then the we have our source, the number of plane at source. So we do k by source plus k% source, because if any remainder is there, we have to come back for that also. So that will be the number of trips I have to do, and 2 into this minus 1 will tell me the time, and then that I can add to the max time. So I know it was a little bit confusing, but if you write it down on a piece of paper, it will get easier to understand. I'll also show you my code. So right from the beginning what I've done. So as I said, I've taken in a of I. I'll just no need for this. Yeah. So I've taken in the array a of I, and I've taken in the array b of j. I've sorted both and then reversed both. And as I said, if b of 0 less than a of 0 minus 1, then I is equal to 1, j is equal to 1, time is equal to 1, source is equal to m minus 1, destination is equal to 1, and max time initially as minus 1. So like I said, if b of j is less than a of j, meaning that if the, for example, I come to this I and j. So if b of j is less than a of I, if b of j is less than a of I, meaning that the current plane cannot accommodate its corresponding, so we have to call the previous plane back. And for calling the previous plane back, we add 2 to its time and we update max time. Then j plus plus I plus plus and time is equal to 1, meaning that this is while. So if while b of j less than a of I, so while all the groups which cannot be accommodated by my current plane, I finish all that using the plane which can accommodate, and then the new plane which is able to accommodate, for that time is equal to 1. Then again source minus minus, destination plus plus, because that plane flew with the passengers. Now this is the case if j is equal to m. J equal to m meaning that all the planes are finished, and I not equal to m meaning that the groups of people have not finished. So if source greater than equal to n plus I, then max time plus plus break. Otherwise source is equal to m. This is actually redundant, not very useful, but this is the main thing in the else part. So as I said, source is equal to m. Source is equal to m meaning I've called all the planes back to the source, max time plus plus, which took me max time plus plus. And if source is greater than equal to n minus I, then max time plus plus, meaning that we only need 1. Otherwise, as I said, n minus I, which is the number of groups left by number of planes at source, plus the number of groups left modulo the number of planes, and 2 in which will be the number of trips. And 2 into k minus 1 added to max time will give me my max time. So this is how I solved it, and it took me some time because I was getting one test case wrong. So again, to put it in a nutshell, what I'm doing is, if the first plane is not able to accommodate the first group of people after descending, sorting it in descending order, then answer is -1. Otherwise, I is equal to 1, j is equal to 1, and time is equal to 1, which is for the first plane. And if the, I'll just explain from my code itself. So yeah, so I is equal to 1, j is equal to 1, and source is equal to m-1, destination is equal to 1, meaning the first plane which could accommodate has already flown to the destination. And then while I is less than n to accommodate all the groups of people, and while b of j is less than a of I, if the current plane is not able to accommodate, if the jth plane is not able to accommodate the ith group, then we have to call the previous plane back, and meaning that we'll be adding 2 to its time. And once it is able to accommodate time, its time will be 1. And then the last case that if there are any, if all the planes are at destination, and if there are other planes left, then we call all the planes back to the source, and then it's just simple mathematics. So if four planes are left at four groups are left, and we have three planes. So basically, the number of how each plane will travel to with one group. So 3 plus one plane will have to come back and then go with it plus 1. And from that you can calculate the time taken. So that's pretty much it. I know it was little confusing. If you have any doubts or if I have missed something, then do write it in the comments. And that's all. Thank you.